Okay, students, let us see this question. First one, methylene blue in aqueous solution is adsorbed on activated charcoal uh, at 25 degrees centigrade. For this process, the correct statement is the the adsorption requires activation energy. No, because this is a simply physis option. So this one is incorrect. Adsorption is accompanied by decrease in enthalpy, which is correct because either physisorption or chemisorption, adsorption enthalpy will always be less than zero. The adsorption increases with increase in temperature. That is also incorrect because adsorption decreases for physisorption. The adsorption is irreversible. That is also incorrect because physisorption is reversible. 1, 2, 3 are the isotherms. T1, T2, T3 are temperatures given. How are they going to vary? This is from Freundlich isotherms. We have directly learned this, correct? That is T3 will be greater than T2 will be greater than T1 at any particular pressure. So that should be answer 2. Next, a detergent solution becomes a colloidal sol at concentration 10 raised to power of minus 3 on an average of uh, 10 raised to power of minus 3 molar on an average of 10 raised to 13 colloidal particles are present in 1 millimeter cube. What is the average number of ions which are contained by one colloidal particle? That is 1 Michel particles. Okay. Okay. So from here, what we can do, one second. See here now, we can say that number of here, uh, as per the question, we are supposed to calculate here the average number of ions which are contained in one colloidal particle, that is 1 Michel. So for that, what we can do, first we can calculate the total number of particles. So let me write down that number of uh, sodium lauryl sulfate, which is the product here, number of ions which will be present will be equal to 10 raised to power of minus 3, which is the concentration, multiplied by 6.023 into 10 raised to power of 23 into 1 liter. Correct. So this would be equal to 6 into 10 raised to power of 23, 20 per liter. So in 1 liter, we can say that, right? Sorry, this is per liter. So we can say these many number of ions are present per liter. But what about 1 meter cube? So 1 cube will be equal to 6 into 10 raised to power of 23 multiplied by, okay, uh, per meter cube will be into 10 raised to power of minus 6. So that would be making it as 10 raised to power of 14. These are the number of molecules present per millimeter cube. Okay. Next, let us see how many Michels are formed. So number of Michels would be equal to 6 into 10 raised to power of 14 divided by 10 raised to power of 13. Because if you check out the question here, we have 10 raised to power of 13 colloidal particles here. So in this case, this would be the number of Michel particles. Got it. So we got the number of Michel particles from here. So if you solve this, we would get it as 60. So that is a question asked. How many Michel particles? Okay, students. Let's see the next one. 1 gram of activated carbon has a surface of 1000 meter cube, considering complete coverage as well as the mono layer of adsorption. How many ammonia at 1 atm and 273 kelvins would be adsorbed on surface? Okay, now let us see this question. So here I could say that uh, total surface area, total total surface area would be equal to 44 by 7 into 10 raised to power of uh, 3, 10 raised to power of 3 meter cube. This much is the meter cube. So that if you write in terms of centimeter, that will become 10 raised to power of 4, sorry, into 10 raised to power of 3 centimeter square. This is meter square. So this is the total surface area. We got surface area, radius of the uh, particle is given, which is 10 raised to power of minus 8 centimeter. So which means surface area of NH3 will be equal to pi r square, which is equal to 22 by 7 into 10 raised to power of minus 16. Got it? Because it is 10 raised to power of minus 8 whole square. So now this is also in centimeter square. So from here I can calculate number of NH3 molecules adsorbed will be equal to this 44 by 7 into 10 raised to power of 7 divided by 22 by 7 into 10 raised to power of minus 16, which is 10 raised to power of, sorry, 2 into 10 raised to power of 23. So what will be the volume? Let me put it here. Volume of NH3, will be equal to 2 into 10 raised to power of 23 divided by 6 into 10 raised to power of 23 into 22.4 liters at STP. So that would be equal to approximately it is coming as 7.46 liters. So that is how you can solve it. I guess that point is clear. Right. Next, what is the correct sequence of the decreasing coagulation value of the following electrolyte for the coagulation of ferric hydroxide salt? Okay. So if it is about ferric hydroxide salt, which means we know it is a positively charged salt, so we need a negative part of it. So if you see that least would be for uh, we need coagulating value, not the power here. So power means lower value, coagulating value means higher. So KCl will have the highest, and least would be for this one because this has valency -1, this has valency -4. So 2, then this is -3, this is -2. So I think that is matching with the second one. Next, on addition of AgNO3 to Ki, negatively charged colloid sol is obtained when it is. Okay. We just check out the excess here now. If it is negatively charged, I minus has to be the surrounding one with it. So if you see 50 into zero point 0.1, 50 into zero point 0.1, it is equal. 50 into zero point 0.1, 50 into zero point 0.2. So we can clearly make out that this is more. Ziegler-Natta of ethylene. Okay, Ziegler-Natta is a shape catalyst. So that is the uh, catalyst which it has TiCl4, got it, plus AlCl3. This is the combination which it has. Okay, right. So here if we check it out, sorry, this is aluminium with Et thrice. This is how the structure would be. Got it. Now in here, if we check it out, titanium's oxidation state here, because it has +4, means it is +3 here, because overall titanium will have 4s0, 3d, sorry, 4s2, 3d2, right? Here, if you see the structure, how it is, this TiCl4 would actually exist as TiCl3 plus Al Et thrice Cl with minus and plus. Basically, chlorine is the donating part here. So if you see the oxidation state on titanium, it is +3. So that's how it is getting it as +3. And this is the part which is an activating species on which ethylene get polymerized. Okay, guys. Next, let us see the next part of it here. So which is 38. Right. In 38, what is it given? What is the equation of Langmuir adsorption under high pressure? Okay. So first, If you check out Langmuir's adsorption, Langmuir's isotherms, this is X by M is equal to A into P by A plus BP. This is the one. So we can say that at high pressure, at high pressure, this pressure part is very high. So A can be ignored here. So I can write this as AP by BP. So PP will get cancelled. X by M is equal to A by B. So X by M is equal to A by B. So that will be this answer. Next, the catalyst used in manufacturing of hydrogen by Bosch process is, okay. So hydrogen by Bosch process, which has been used here. Yeah, here on the basis of C plus H2O, on heating is forming CO plus H2. Now, the catalyst which we use is, Fe2O3 and Cr2O3. That's how we prepare H2 gas in this. So just remember that catalyst here. I think you may have come across this for the preparation of H2 before, if you remember. Next, which of the following gases is absorbed most by the activated charcoal, right? For that, we need to check out the critical temperature here, all right? So we can easily guess on the basis of molar masses, CO2 is more, so that will have more critical temperature. Next, gold sol is not a, okay, is not what is, it is a lyophobic, which is correct, negatively charged correct, macromolecular and multimolecular colloid. Okay, so this is not a macromolecular, it is a multimolecular. Multi atoms would be present with an electron getting embedded in it. Next, select the non-elastic gel out of the following. 42. uh, if you see that all of this starch, agar agar and gelatin, they would have some jelly feeling on it, except silicic acid. Silicic acid is this. We have silicon with OH, 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 and OH. So that will be strongly bonded, got it? And it will have hydrogen bonding from all the four ends. So it will keep polymerizing like this, right? I mean, to say, sorry, it will have a hydrogen bonding here that would make it very close and give a precipitate feeling, but it is not elastic in gel. So this is the form. Next, calcium crystallizes in FCC unit with 0.55 nanometers. Calculate the density. It contains 0.2% Frankel defect and 0.1% uh, Schottky defect. Okay, check this question now. Here, it is being asked to calculate the density. See, what we can say that normally density is Zm by A cube into Na. Now this Z effective is changing because there are some defects. See, Frankel defect does not make any difference because in Frankel defect only cation get dislocated, but it is not lost. But in Schottky defect, one atom is completely lost. Correct. So what it is saying, out of every 100 atoms or out of 100 crystals, one NaCl is lost. Or I'm taking NaCl as an example here, since it is FCC. Sorry, one calcium is lost here. So, which means for every 100, if it is one calcium lost, Z effective per unit cell is 4. So, for 4 atoms, how much will be lost? So, for 4 atoms, how much will be lost here? So, this is not 1, sorry, this is minus 1. So, for 4 atoms, there will be loss of 4 into 0.1 by 100. So, the effective atoms per unit cell is 4 minus 0.4 by 100. So, this is Z effective. So once you know this, we can calculate density. So density would be equal to 3.996 into 40. This is the molar mass of atomic mass of calcium. That divided by A cube. A is, I think, A is given how much? Yeah, 0.556 into 10 raised to power of minus 9. Okay, that I need the answer normally in grams. So sorry, per centimeter. So I'm taking it in centimeters. So this will whole be centimeter whole cube multiplied by 6 into 10 raised to power of 23 approximately. So this has a little bit of calculation here. I think this comes to be around 1.55 grams per centimeter cube. So this is how much you would get. Okay, guys. Don't worry about the calculation part. Uh, Try to guess it as almost 4 here, then take 6 here. This you can take it as zero point 0.6 and try to get the closest value of it. So from there you will get, as 1.55. Next, check out the next question here. Analysis shows that nickel contains nickel ion with 96% with D8 configuration and 4% with D7. D8 D7 is simply implying that nickel is at +2 with 96% and nickel is at +3 at 4%, right? So if we take that, you just need to check out the formula. So which means for every one oxygen, what will be the number of nickel here? 0. Let me just 96 and 4%. Yeah. So 2 times, which is the charge of nickel into 96% plus 3 times into 4%, right? So this much is the total percentage. I mean, this much is the total amount per, this much is the percentage per whatever the amount that has been given here. So one second. So here we have been given 2 into 96 plus 3 into 4 minus 2x. Got it? So this is the, sorry, minus, how much is the charge here? Yeah, minus 2 times of x, which is the amount of oxygen. That should be equal to 0, because in any molecular formula, if you check out nickel, Ni, X and Oy, overall has to be 0. It has to be neutral. So this is what it is. Suppose there are Y amount of, there is here Y, I'll take Y amount of oxygen present. 2 is the charge on it. So the total charge should be equal to 0. So if we calculate Y from here, Y is coming out as 1.02. Since it is 1.02, which means it is nickel 1.00 and oxygen 1.02. So because the impurity is with the nickel, just divide everything by 1.00 divided by 1.02 and oxygen as 1.00. So this would come approximately 0.98 and oxygen as 1.00. So this will be the formula. Check out the answer back again here. Yeah, I think that is 4, which is matching. Yes, all of you understood that. Let us see the next question. The oxide which shows metallic conduction here, okay, rutatium. This comes below chromium, right? Sorry, cobalt. So if you check out Re here, okay, right. So check it out. R comes in, sorry, no, under manganese. So if you check out manganese, okay, technetium and R here, this is what you'll get. This is manganese, Mn, yeah. So which means the configuration would be somewhere about Ns2 and Np5, 7 electrons, but it is +6 oxidation state. So which means there is one unpaired electron. This is vanadium oxide. The structure is not, I mean, the structure isn't given properly. The symbol isn't given properly. Vanadium has Ns2, Np3. So remove 2 electrons. So 3 unpaired electrons. Chromium, which is supposed to be Ns1, Np, Nd, N minus 1d. Here also what I'm writing, sorry. This is N minus 1d. Here also it is N minus 1d. Okay. So here it is N minus 1 and 5 here. So remove 4 of them. So when you remove 4 of them, so there are 2 unpaired electrons in D. This is the 2 unpaired electrons. So you can see all of them have unpaired electrons. So definitely they will show metallic conduction. Got it? Next, 46th. 46th, we have done this before in the class. So hopefully all of you got that. So you will get this as number of cation vacancies you need to check. We have 10 raised to power of -3 moles, which makes it 10 raised to the power of minus 6 vacancies, right? So 10 raised to the power of minus 6 vacancies here, and sorry, minus 5 vacancies there. That multiplied by Avogadro's number. So that's all you need to get from there. So you'll get this as the answer. Next, 47th, if you check out, the flame color of metal ions is due to, flame color of metal ions is due to, yeah, metal excess defect. So whenever you have metal excess, that is why the electrons would glow there. I mean, electrons would be present inside the fab centers, so that will glow there. Next, for silicon, given conduction band here, wavelength of the light that excites an electron from valency of valence to the condensed band in the silicon is. So we just need to put out the values and get it. That's all. It is per mole given. So 1 mole is giving 115 kilojoules of energy. So which means 115 into 10 raised to the power of 3 joules. So one atom, which means I have to uh, check out for number of electrons. So because I'm assuming here the number of electrons. So if one electron has to go from valence band to conduction band, then what will be the number of atoms? If this much amount of energy has been coming, then this is for how many electrons? This is for 1 mole of him, correct? So this entire energy is for 1 mole. So if at all I take it for one atom, how much that will be? It is 115 divided by Avogadro's number into 10 raised to 3 into 6 into 10 raised to the power of 23. This much energy per electron, and this is in joules, right? So we got the energy per electron. So we know lambda will be equal to hc, lambda will be equal to, because E is equal to hc by lambda, so hc by E. So H is Planck's constant, you know that value, into 3 into 10 raised to the power of 8, correct? So into that divided by energy, which is 115 into 10 raised to the power of 3 divided by 6 into 10 raised to the power of 23. See this value above, that comes approximately as 2 into 10 raised to the power of minus 25. Remember this for easy calculation, into 23 divided by 115 into 10 raised to the power of 3. So on solving this, you will get it as 100,1039 into 10 raised to the power of minus 9 meters, so which means nanometers. So I think 10 raised to, no, sorry, 9 raised 10 raised to the power of minus 12 meters you will get. So we will get this as 1039 picometers. Got it? So how much we got here? 10 raised to the power of minus 9. I took that. Let me check once again. This is minus 20. This is minus 2. And this will bring it as minus 5. 112 makes it minus 7. And then, yeah, on dividing that, this would be 10 raised to the power of 12. Minus 12 meters. Yes. Right. Next. If non-metal is added to the interstitial site, okay, the question says, if non-metal is added to the interstitial site of the metal, then the metal becomes, okay, the metal becomes, whenever a non-metal is added, like for example, if we add carbon to metal, so it will become hard, as well as it will have more ductility effect. Got it? This will have more ductility effect. Again, this is slightly out of syllabus as of now. I would suggest this would be difficult to answer because this is something which you'll learn in D block. Okay. Next, which of the following statement are true? See the 50th one here. So which of the following piezo electricity is due to the net dipole moment? Correct. So because on pressing, On mechanical pressing, there is a charge that is created on either of the side. Ferroelectricity is due to the alignment of dipoles in the same direction. That is also correct. Pyroelectricity is due to heating. That is also correct. So all of these are correct here. Okay, students. Next, let us see few integer type questions now. Okay, so this question 51 is easy. Here you can see that log of x by m is equal to log of k plus 1 by n into log of p is the Friendlich equation. Y-intercept is given log of 3. You can see that intercept value is given. So from there I can say k is equal to 3. And also if you see the tan theta, we can say that 1 by n is equal to 1, implies n is equal to 1. Right. So this value is given. So, and pressure is also given. So we can calculate what is x by m. So x by m is equal to 3 times of pressure, which is 3 raised to power of 1. So 9. So I think you will get the answer as 9. Next, let us see the next question here, students. See the next question. It says that for the coagulation of 100 ml of arsenic sulfide with NaCl, 5 ml of 1 molar NaCl is used. Calculate the flocculating power. Okay, flocculating power should be, sorry, value should be in the basis of millimoles per liter. So you can see that for 100 ml of solution, correct, we require 5 ml of 1 molar NaCl. So if I take 1000 ml, that would require 50 ml. So 50 ml of 1 molar NaCl. So 50 ml of 1 molar NaCl is 50 millimoles. Correct, that's all. So the answer asked is for how many millimoles per liter. So that should be 50 millimoles. Okay, simple question there. See the next question here. It says gold number of hemoglobin is 0.03. See, gold number is always defined for 10 ml of gold salt. For 10 ml of gold salt, the gold number is 0.03. So if you are taking 100 ml, then how much will be the uh, required milligrams of hemoglobin? So 100 into 0.03 divided by 10. That's it. So 0.3. So the answer is pretty simple here. So this is 0.3 because he asked in milligrams only. You don't have to change anything there. Okay, students. Okay, let's see this now. 3.6 grams of O2 is absorbed here. We know that 1 mole, which is 1 mole of O2, will occupy 22.4 liters volume, liters at STP. So, which means 32 grams of O2 is occupying 22.4 liters. So 3.6 grams will occupy how much volume? So 22.4 into 3.6 divided by 32 liters. This much volume is occupied. Right. So we got the volume here. Next, but this is for 1.2 grams. So for 1 gram, how much it is? So 22.4 into 3.6 divided by 32 into 1.2. So just have to divide with that. So you will get across 2.1 liters per gram of adsorbent. So answer should be 2.1. Okay, students, I guess you got that. Okay, let's see the next question here. It says X-rays strike at this lambda value and theta is given here, angle is given. So we know the theta value, n value is given. We just have to use the Bragg's equation. If you recall, Bragg's equation is n lambda is equal to 2d sine theta. Okay. So from here, d is the distance between the planes, that is equal to n lambda by 2 sine theta. So n is 1, lambda is 1.54 divided by 2 into sine of 22.5. So which is 1.54 by 2 into 0.383. So we need to calculate the distance between the plane that are responsible here. So how much we are getting? We are getting this as 2.01 Armstrongs. Okay. I hope you guys have mentioned that in Armstrongs. If anyone has mentioned other than Armstrongs, just let me know because here it is not mentioned. Hopefully you all have, sorry, mentioned in Armstrongs only. In case if there is any nanometer or anybody has mentioned anything, please let me know. Okay, guys. See this question now from the given how many coagulate the hemoglobin sol. Hemoglobin is a positive sol, so we just need to check out the negative ones. So this is positive sol, positive sol, positive sol, negative sol, negative sol, negative, negative. Okay, basic dye is also positive. So which of them are negative sols here? So four of them. So four of them are negative sols here. Okay, students. See, next one is about the particle size of the suspension that should be greater than. So normally when it comes to colloid, it is 1 nanometer to 1000 nanometers. Correct. So if you write it in terms of Armstrong, it is 10 raised to power of minus 1 Armstrongs to 100 Armstrongs. Sorry, how much it is? 100 Armstrongs here. Right. So this should be the size of it. Okay, because when you're writing in terms of nanometer, you express that in Armstrongs here. So 1 Armstrong is 1 minute. Sorry, I made a mistake here. So this is 1 Armstrong, which is equal to 10 raised to power of minus 1, and 1 nanometer is 10 raised to power of minus 1 Armstrong, and this is 100 Armstrong, so which is correct, 10 raised to power of 2. So X should be equal to 2. So suspension particle should be greater than 2. Okay, I guess that is clear. Next one, if you see in oxalic acid, so first KMnO4 with oxalic acid C2H2O4. On reaction, first it will form Mn plus 2 plus CO2. And this CO2 further helps for the reaction to happen. That's how autocatalysis will take place. Got it? So this was there in the paper which I gave you. Few of you have asked doubt about this as well. So hopefully you guys have got it right. Now you need to check out the number of unpaired electrons on this. Number of unpaired electrons, this is 4s0 and 3d 5. Correct. So number of unpaired electrons on this would be 5. Okay. I guess that is clear, everyone. Let us see this question now. How many of the following are antiferrous substances? Okay, as per NCRT, we know that MnO is given. Well, others are also, there are a lot of antiferro molecules here, but I don't think that is there in our syllabus to understand. So I'm opting for delete. But nevertheless, it is no harm to learn it. So MnO2 will also show the same characteristic. Mn2O, FeO, Fe2O3, NiO, Cr2O3, COO, cobalt, this is CO3O4, this one will show. Water, not NaCl, not, and this one, no. These are all diamagnetic. Okay. So just note that, but learn it for advance. But I don't think that is needed for JEE mains here. Okay. See this now. Increase in pressure of a gas cause the amount of adsorption to increase, which is correct statement. Sorry, this is increase, he said. So that is wrong. So which means this is a false statement. Increase in temperature may increase or decrease the amount of adsorption. Okay. So which is correct, because we would see in case of chemisorption, first it would increase and then it will decrease. The adsorption may be monolayer or multi-layer. Okay. So that is also correct. And particle size of the adsorption, how many following statements is false? So first one is definitely false. Increasing of pressure of a gas causes the amount of adsorption to increase. No, I think that is true only. Increasing pressure will always increase the adsorption. So this is also not false. Let me write it this way. Okay, true here. Increase in temperature may increase or decrease the amount of adsorption, which is true, because for chemisorption it may increase, for physisorption it may decrease. The adsorption may be monolayer or multilayer, same is the case. Particle size of the adsorption does not affect the amount of adsorption. Okay, particle size of adsorption does not affect the amount of adsorption. Well, it does, because if you see that bigger the particle, more amount of surface area it will occupy, so less amount of adsorption it will take. So this is a false statement. So first three are true statements. So only one is incorrect here. So fourth one. How many following statements he said? So only one statement is false here. Okay, students. So I hope you got this, everyone.